Assalamu alaikum warahmatullahi ta'ala wabarakatuh. Bismillah ar-Rahman ar-Rahim. Ladies and gentlemen, let's continue the HHO or hydrogen generator project. In this video, I'm gonna talk about the details of the design of the dry cell. The previous video we talked about a quick overview about the all production methods, and we showed the benefits of the HHO dry cell and the disadvantages of the wet one. So in this video we have here, so this is the inlet cover. We have here two ports. According to the design, you can make your own design. So here is the threaded two inputs for the water and the outlet. We have here one for the O2 and on the other for the H2. Then we have the positive or negative stainless steel plate, and then the gasket or the rubber gasket here. This we talked about the slot, and here is the blind gasket, and here the neutral plate. And of course, if you wanna get hydrogen without the oxygen, you must have this membrane, okay? And if you don't wanna get the membrane, or you only wanna the HHO or the hydroxy gas, hydrogen plus oxygen, you you do not have to get this membrane, okay? But this can be used only for the quick or the direct usage of the hydroxy gas, like in cars, okay? So here is the assembly of the cell. Notice that it's a quick assembly. We have here the inlet cover. Okay, let's see. So this is the details of the this part, all the dimensions. It's 12 here millimeters according to the standards, according to the diameters of the pivots or the connections here of the pins. You have to know these values. Very simple. And here is this is in millimeter, 152, okay? And here is also, and this also here, okay? So it's very simple. And also the outlet cover, find here the other part, and these are here are the dimensions. Of course, you have to follow the standards for your model. And the positive stainless steel or the negative stainless steel plate is used here, okay? Here is 13 because this includes the cover of the pivot or the pins. Of course, you can see a lot of designs to you can follow it. Okay, so here the blind gasket also is very simple. Here is 1, 2, 3, of course, and here are the dimensions, and of course this is the membrane, and here are the neutral plate. We're gonna watch a video about the neutral plate and its importance, and here are the gasket. Okay, so the gasket, so here is the gasket. Of course, you can make this slot by the laser, cut it by the laser. Of course, these designs must be done using the CNC high quality machines to get the slots as you see. So now here is the assembly. You have to watch the videos of the assembly in the previous tutorial, or any YouTube video to see exactly what's going on or how to assemble. It's just you begin with the cover, and then the positive stainless steel, and then the rubber gasket and the blind gasket, and then the membrane, and then the neutral plate. Of course, very easy, and so on until you reach the 19 plate cells, 19 plate cells, the cell, 19 plates cell, and then here are the hoses for the water, for the inlet, and here are the 2 ports for the oxygen and hydrogen. If there is no membrane, you only have to make 1 hole for hydroxy. Yes, so I think this is very simple to be done and to be manufactured. Very, very simple. Actually, now let's see, or let's watch a video about the neutral plates.
Hi, I'm Mike Shaheen with HHO Connection. This is the third video in a short series geared towards people who are just getting into HHO and want to learn some of the basics. The topic today is going to be neutral plates. This is probably the #1 question that I get asked is, what the heck are neutral plates and why do I need them? It's actually very simple. I've come up with what I think is a nice little demonstration so to help you visualize what happens when you start adding neutral plates. In a nutshell though, it's all about the electrolysis process, in that if you take 2 pieces of stainless steel and you dip them into an electrolyte, say you got 2 pieces of metal like that, you put 12 volts between them, that's great, you're going to get a lot of gas, but the problem is anything over, let's say 2.2 volts is wasted. You start noticing bubbles around 1.8 volts, optimum is somewhere around 2 volts, 2.2 you're hitting about the limit. Anything over that 2.2 volts, and it's basically just wasted. It's wasted energy, and it's going to create a lot of heat. That's why that you see, when you see cells out there that don't have neutral plates, they're just running, especially the ones who just run either 2 wires or 2 plates, they heat up really fast, and within no time you're not even generating HHO, you're just generating a lot of steam. So let me show you in real simple terms what neutral plates are all about and why you need them. So here we go. Let's say this is our generator, and we have 2 plates, and we're going to send that a 12 volt source. So now what we've got is one big plate gap here with 12 volts in the middle of it. Now let's say we add 1 plate in the middle of here, but we don't connect it to anything. This is our neutral plate. We're going to stack that right in the middle. So now, instead of having 1 big plate gap, we've got 2, 1 and 2. And if you were to take a voltmeter to this, what's happening now, let's say this is your positive and this is your negative, as a current goes through here, it has to pass through this plate now, which is going to lower the voltage. And if you were to take a meter, let's say these were all perfectly spaced, and if I were to take a meter between this plate and the other outside plate, it would read 12 volts still. But if I were to take a meter between this plate and the middle plate now, because I've got 2 plate gaps, it's only going to read 6 volts, because we have a 12 volt source divided by 2 plate gaps, which gives us 6 volts. So if I read between this plate and this plate, it's going to read 6 volts. If I read between this plate and this plate, it's going to be 6 volts. every time we drop another plate in between, it's going to make another gap, and so we have to take our 12 volts and we have to divide that by another number. So if we keep on adding these plates like this, these are my neutral plates going in. Let's do a 7-plate configuration, which is really common. Okay, I'm going to put one more plate in there. Okay. So now you've got 7 total plates. You've got a positive on one side and you've got a negative on the other side. And you got 5 neutrals, 1, 2, 3, 4, 5 in between here. So now it has to pass through a total of 6 plate gaps. 1, 2, 3, 4, 5, and 6. So that means now you take your 12 volts, you divide that by 6 plate gaps now, and that's going to give you exactly 2 volts per plate gap, which is perfect. If I were to take a meter and meter, again, between the 2 outside plates, it's going to read 12 volts. But if I go between any other 2 plates that are next to each other, let's say I take a reading between this plate and this plate, it's going to be 2 volts. And as long as your spacing is consistent, that's why we use the 1/16 inch gaskets and try to keep everything as flat as possible, because the more consistency that you have between all your plates, the more consistent your voltage is going to be between any 2 plates. And that is neutral plates. I'm going to put some probes from a voltmeter to the dry cell and take a reading on the different plates that are next to each other so you can visualize what I was talking about. Now if I put the probe on the first 2 plates, you'll see it reads just about exactly 2 volts. And in theory, as I move across those plates, I should add 2 volts for every plate as I go across. So now I'm going to move the probe over one more plate, and you'll see it reads 4 volts. Move it again. There's 6 volts. One more time. Here's 8 volts. One more time. 10 volts. And the last plate in one series, there's 12 volts. So that's basically one stack, a positive and a negative, with 5 neutral plates in between, giving you a total of 6 plate gaps and 2 volts between plates. Now if I take the reading between any 2 plates that are side by side in here, you'll see it's almost exactly 2 volts. Hope it makes sense. As you can see, the concept of neutral plates really isn't all that complicated. It's all about lowering the voltages between your plate gaps to down below 2.2 volts. Now, if in a perfect world, if you had a 2-volt power supply, you wouldn't even need any neutral plates. But not many of us are working with a 2-volt power supply, so you need neutral plates. If you're going to be putting this thing in a car and you're dealing with 13.5 volts, you should probably consider running 6 neutral plates to try to get those voltages down. You can run 5, but it will have a tendency to overheat a little bit over time if you're running 5 neutrals. Other than that, one thing to consider is as you add the neutral plates, you're going to have to add a little bit more electrolyte. It's not going to draw as many amps as you start adding those neutral plates in there. So it's just something to keep in mind, that you might have to beef up your electrolyte solution a little bit as you start adding those neutral plates. Anyway, I hope you learned something. Take care. Be safe. We'll talk to you soon.
Also, gentlemen, after watching the video, we have the bubbler, and the bubbler is very easy and you can make it by yourself. No need to be shown again here. Just bottle with something special, and we have to know the flashback arrestor to avoid any problem with the hydrogen. You know that this gas is extremely dangerous, so let's take a look on how to do the design of the flashback arrestor.
Hi, it's Mike Shaheen with HHO Connection. Today I want to show you how to build the little white flash ports that you see on top of my bubblers. Now if you're new to HHO, let's just do a quick refresher. This is a bubbler and this is the flash port on top, and the only purpose of it is like a pressure relief valve. When you have a flashback come into your bubbler, it's going to ignite all the HHO gas that's accumulated at the top, and you need to blow that pressure off somewhere. It's a really simple device. It's made out of PVC from parts you can buy at your hardware store, and inside this little thing is nothing more than a mouse ball. And when I say a mouse ball, I mean, you know, the mice that you use for your computer, the old style, had the little rubber, the metal ball that was covered in rubber inside it. That's what's inside it here. There's a mouse ball with a 3-inch spring inside a couple pieces of PVC, and that's all it is. And the concept is really simple. You've got a small opening at the bottom down here, and the mouse ball is pressed by the spring up against that opening to seal it off. And in the event of a flashback, the air pressure just pushes that ball up. You can see through the little hole here. It just pushes the mouse ball up and releases all the air out here. So, very simple device. I'll show you how to make it. It'll take you probably about 10 minutes once you have the parts. These are the different components that you're going to need in order to build the flash port. You're going to need some sort of PVC glue. I use this stuff called Christie's. You'll need a spring. This particular spring is 3 inches long. It's 5/8 of an inch across this direction. And I don't know the pound strength of it, but if you notice, I can squeeze it completely with my fingers with, quite a bit of effort. You don't want a spring that I picked up some that I could barely mash at all. It was just way too tight, I think. This seems to be a pretty good one. Again, 3 inches long, 5/8 of an inch across that way. You need a mouse ball. You need a small piece of 1-inch PVC pipe. This piece is cut to 1 3/4 inch in length. It doesn't have to be real exact. You'll need this little piece here, which I believe it's called a reducer. It takes a 1-inch PVC pipe this direction and reduces it down to a 3/4 inch opening on this end with threads here. And then the last piece you need is this little cap that's going to go on the end of this and form, which forms the flash port. So let's show you how it all gets put together. Okay, the first step is to take your piece of 1-inch PVC pipe and put a little bit of your PVC cement on there. So I'm just going to take a little bit of this around the edge here. And we're going to put a little bit on the inside of this reducer piece, like so. And just going to insert that piece into there like this. Get it all the way in until it seats all the way to the very bottom, just like that. Okay? That's what you should end up with. Okay, I've given it about 10 minutes now for the glue to dry inside here. And the next step is to drill some holes through this PVC piece here. Now if you look down the center there, you're going to have to drill through both these layers. You want to go all the way through. So again, I'm going to take a 3/8 inch bit and I'm going to drill 3 holes around this. So I'm going to cut the camera. I'll come back after I'm done drilling. Okay, so I've got the holes drilled now. As you see, I've got 3 3/8 inch holes drilled around there. And all we're going to do is take the mouse ball, we're going to drop it in there like so, take the spring on top of that, and then we're going to cap it off with this guy like that. Now I'm holding it together. I'm just going to get some glue and glue that together, but that's how it's going to go together. So, let's take out the spring, take out your mouse ball, grab some glue. You're going to apply a little bit of glue to the outside of here. And the inside of your cap. Okay. Take that, drop your mouse ball in, drop your spring, grab your cap, press it all together. Hold on till the glue sets. It'll take a couple seconds. And there you go. There's your flash port. All you got to do is let the glue dry now, and you're ready to go. Well, there you go. That's how I build my flash ports. Like I mentioned, it's a very simple design, but it works really well. So now you have no excuse. Whether you build one like this or your own design, put a flash port on all your bubblers. Take care.
Okay, we can see a video from YouTube. It's a quick animation for the whole system, and after it we can see a 3D animation of the assembly of another cell. It's very easy to know, and you have to search please about many other videos. I'm just here showing you the details of the designs. I think it's pretty easy. Look, nothing, it seems nothing to you. Then you can manufacture these components and just watch the videos and to know how to install them and to get the benefit from the water into fuel. Okay, so let's see the other videos.
Hi, it's Mike Shaheen with HHO Connection. Today I want to take a look at the 31 plate dry cell that's being made by Green Fuel H2O. This is a cell here, and I gotta say, I'm really impressed with it. It's a very, very well made cell. I'll turn it sideways here so you can see. The way that they got it set up, you've got inlet ports and outlet ports on both sides. It helps with the circulation of the cell. Now everything about it is just pretty much top notch. He uses 316L stainless steel. It's all laser cut plates. These are 4 inches by 6 inches. The power plates all have holes drilled through them so that you can bolt the electrical connections directly onto it like that. There's no need to go through little connectors like I'm used to with the EBN type cells. The electrical connections, just 2 easy bolts, positive and negative, right here on the front. Pretty simple, pretty cut and dry, very easy to assemble. Nice little unit. So let's fire it up and see what she does. Okay, so I got the cell running now. I'm using my benchtop power supply, and I'm putting out 12 volts, and I'm running at about between 17 and 18 amps. My cell temperature, we're looking at about, it's saying 105, 104 there. Water temperature showing a little bit higher. Water temperature showing 111. So let's go with that. Say 111 on the temperature, 12 volts. We'll call it 17 amps. I got a ½ liter bottle we're going to measure. Get my stopwatch ready. Zero it out. And here we go right about now. And close, and time. So we got 29 seconds. 29 seconds, 12 volts, and we're going to call it 17 to 18 amps. That's pretty good numbers there, okay? It's not the most efficient cell, but I'll tell you what, considering the price, the quality of this thing, this is a really, really nice cell. I gotta say, I'm impressed. Good job, Green Fuel H2O. Well, that's the 31 plate dry cell from Green Fuel H2O. They are available in other sizes as well. They have a 13 plate dry cell, a 19 plate. They even have a 59 plate AC unit that plugs straight into the AC on your wall. No need for a DC power supply. And all their kits can either be bought pre-assembled, or you can buy them as a do-it-yourself kit if you want to assemble the dry cell yourself and save a few dollars. Now, if you do want to put one of these inside your car, they also have installation kits available as well, which include things like water reservoirs and the cables and connectors and all the electrical components you'll need to get hooked up. So, we are representing Green Fuel H2O as one of the vendors on our site now. We are offering HHO products for sale, and Green Fuel H2O is one of the vendors. I am very proud to represent them. They make a quality product, a very fair price. So if you need a dry cell, go to hhoconnection.com. You can buy them directly off our website now. And if you have any questions whatsoever, feel free to drop me a line at mike@hhoconnection.com. Thanks a lot. Take care.
Okay, gentlemen, thank you for watching. I hope this helps you. Please, you have to do many research about these cells and what is the modern technology in it. You have to know how much liter per minute, how many liter per minute you can get, and how to connect it using solar energy or whatever you want. Okay, you have to do a search from Google on Google. Here, the HHO dry cell. Okay, you'll find many techniques. Look, amazing. And here is the reservoir. Okay, and here is the cell. Pretty easy. And here is the bubbler. Okay, here are the electrolysis, how it works. And here's the HHO for the engine. Okay, and here's the in Russian. Okay, it's an air intake manifold. Water, voda. Voda is water in Russian. Here's a simple cell like this, and here are dimensions. That's why it's pretty easy to know these things and to manufacture it. Okay, so the research nowadays is concerned with the heat, the wasted heat from the cell, and how to reduce the cell's temperature, and to how to get the optimum liter per minute of hydrogen. Okay, so it's a field of the optimization and clean energy. And here is a video on YouTube. You will find this video on YouTube, how to install or make the assembly by yourself. You can use it for your car. You can use it as a pure hydrogen storage, as a fuel. Here are the other things. Okay, also you can find solar. So here is the solar. Please watch this video, and here no need to get the power supply. You only can produce your hydrogen using a solar panel. It's pretty easy. These things. Also, you can after this you can check out the fuel cells and how to use the algae for the fuel cells. Okay, Okay, thank you very much, ladies and gentlemen. It's a quick video. I hope it helps you to do a project by yourself. Thank you very much. Wassalamu alaikum wa rahmatullahi ta'ala.